Class 12th chemistry, we were discussing coordination compounds, and in this video we'll discuss about naming of ligands and nomenclature of coordination compounds. First one is some common ligands in coordination compounds. First, unidentate ligand, water, ammonia. These are the neutral ligands. Fluoridine, chloroidine, cyanidine, thiocyanidine, hydroxidine, nitridine, these are negatively charged ion. Okay. In thiocyanidine, either sulfur or nitrogen may act as a donor atoms. That's why, but at a time only one is used. That's why this is the example of ambidentate ligand. The same way, in this nitridine, at a time either oxygen or this nitrogen may act as a donor atom. That's why this is also the example of ambidentate ligand. This is bidentate or didentate. Okay. Ethylene diamine as an abbreviation, this is written as EN. This is NH2, CH2, CH2, NH2. This is neutral ligand. This is oxalate ion. Okay. This is also written as C2O4 2 minus, and as abbreviated form this will also written as OX. Polydentate ligand. This is diethylene triamine triphosphatine, and this is ethylene diamine tetraacetate ion. This is also written as EDTA, and this is 4 negative. Okay, but when these neutral species or anions are used as ligands, they named in some different way. That's why we will discuss the name of ligands. Anionic ligands have names ending in O. For example, halide. This is written as halido. For example, this is chloride. This is written as chlorido. Anion ending in ATE. This will written as ATO. For example, sulfate is written as sulfato. Anion ending in ITE. This will written as ITO. For example, sulfite as a ligand, this is named as sulfito. Neutral ligands are named as such. For example, NH2, CH2, CH2, NH2 as abbreviated form, this is written as EN, and its IUPAC name is ethane 1,2-diamine. Another one is PPH3. This is triphenylphosphine. Actually, this is derived from this phosphine, PH3. If all the 3 hydrogen atoms from phosphine is replaced by this group, PH, and this PH is phenyl group, that is C6H5, then we will get this one. But some neutral ligands are written in some different way. For example, water. This is written as aqua. NH3 as a ligand, it is named as amine. Again, see spelling AMMINE. CO carbonyl, NO nitrosyl. You can see some more ligands in this table, and this table show name of ion, its formula, and when this ion is act as ligand, then ligand name and bonding atoms. Chloride Cl minus chlorido, bonding atom is Cl. Fluoride F minus fluorido, bonding atom is F. Bromide Br minus bromido, bonding atom is Br. Iodide I minus iodido, bonding atom is I. Hydride H minus, as a ligand it is named as hydrido, bonding atom is hydrogen. Cyanide Cn minus cyanido, bonding atom is carbon. Hydroxide OH minus, as a ligand it is named as hydroxido, bonding atom is oxygen. Carbonate, this is a didentate ligand, CO3 2 minus, and as a ligand it is named as carbonato. And in this case, these 2 oxygen atoms are bonding atoms. Oxalate C2O4 2 minus, As a ligand, this is written as oxalato. In abbreviation form, this may also written as OX. In this, again, two oxygen atoms are act as a bonding atoms. Now, come to naming of mononuclear coordination compounds. First, what is the meaning of this mononuclear? Mononuclear means coordination entity in which a single central metal atom or ion is present. Okay, you can see from this, coordination entity may be neutral like this. In this, platinum is a metal atom and this is only the single central metal atom or ion. This is again another example of coordination compound, and in this compound, this which is written in the square bracket, this is positively charged coordination entity, and this is cobalt will act as a central metal atom or ion. Now this is the another example of coordination compound, and in this case this species which is written in the square bracket, that is negatively charged coordination entity, and this potassium is a counter ion, and in this positively charged species this Cl- will act as a counter ion. In some organic compounds, both actually cation and anion may be coordination entity, like in this is cationic coordination entity and this is anionic coordination entity. As a whole, this compound is neutral. Okay, now come to some rules for naming of mononuclear coordination compounds. The cation is named first in both positively and negatively charged coordination entities. The ligands are named in an alphabetical order before the name of the central atom or ion. That is, first we will write the name of ligands in alphabetical order, then we will write the name of central atom or ion. Names of the anionic ligands end in O. We already discussed. Those of neutral and cationic ligands are the same except aqua for H2O, amine for NH3, carbonyl for CO, and nitrosyl for NO. Prefixes like this is di, tri, tetra, etc. are used to indicate the number of the individual ligands in the coordination entity. If same ligand comes 2 times, then we use di. If come 3 times, then we use tri, and tetra for 4 times, penta, hexa, and so on. When the names of the ligands include a numerical prefix, then the terms base, tris, tetrakase are used. The ligand to which they refer being placed in parenthesis. Parenthesis means small bracket. For example, NiCl2PPS3 twice is named as, this is dichlorido. Okay, and then this is triphenylphosphine. Triphenylphosphine. This tri word is already present in the name of ligand. That's why it is coming for 2 times, and that's we will use the word base. Base triphenylphosphine, and this triphenylphosphine is written in this parenthesis, and this is the name of metal, and this is the oxidation state of metal. Oxidation state of the metal in cation, anion, or neutral coordination entity is indicated by Roman numeral in parenthesis after the name of metal. If the complex ion is a cation, the metal is named same as the element. For example, CO in a complex cation is called cobalt and platinum is called platinum. If the complex ion is an anion, the name of the metal ends with the suffix ATE. For example, CO in complex anion, this is anion, negatively charged. This will end as cobaltate. Okay, and CO in cationic species written as a cobalt, but CO in anionic species written as a cobaltate. For some metals, the Latin names are used in complex anions. For example, ferrate is used for iron, Fe. The neutral complex molecule is named similar to that of the complex cation. Now see some examples. This is CrNS3 thrice H2O thrice Cl3. We can say in this case, this is coordination entity which is positively charged, and this is a counter ion which is negatively charged. First, we will write the name of positively charged coordination entity, and in this entity, first we write the name of ligands. Okay, in alphabetical order. That's why this is NS3 which is coming for 3 times. We use the word triamine. Okay, this is water. Again, this is coming for 3 times. That's why we'll write triaqua. Then name of metal, chromium. Then we will write the oxidation state. Now question arises, how can we find out the oxidation state of metal? In the 11th standard, we have discussed the rules to find out the oxidation states. Okay, 2 rules generally we will use. If species is neutral, sum of the oxidation number of all the species is equal to 0. If there is a polyatomic ion, then sum of the oxidation number of all the species is equal to charge on that ion. Okay, we can say this coordination compound is neutral. That's why if we assume that oxidation number of chromium is X, then ammonia is neutral. That's why 0. Water is also neutral. This is 0. Then this is plus 3. This is Cl, counter ion. This is a chloride, negatively charged, and 3 chloride ions are present. That's why 3 into minus 1, and this is equal to 0. If you find out the value of X, this will come 3. That's why this is 3. In Roman, this is written. And this is chloride. This is the counter ion. Again, don't write it a trichloride. Okay, this is Cl3. It doesn't mean that this is a trichloride. Actually, why this is 3 came here in the subscript of Cl? This 3 is the charge on this coordination entity. Again, how can we write the charge? So simply we can say this is chromium. This oxidation state is plus 3. Okay, ammonia is 0. Water is 0. Okay, and this is equal to plus 3. That's why charge on this coordination entity is 3 plus, and charge on the chloride ion is negative. Okay, and charge should be balanced. That's why this 3 is written here. Clear? Now come to the another example. Now in this case, again, this is positively charged coordination entity, and this is negatively charged counter ion. First we'll write the name of ligands. Now this ligand, identify the ligand. This is ethane 1,2-diamine. This di is already present in the name of ligand, and this is coming for 3 times. That's why we use the word tris. And name of this ethane 1,2-diamine will be written in parenthesis. That's why tris ethane 1,2-diamine cobalt. Again oxidation state. Same way. Oxidation state of cobalt is X, plus ethane 1,2-diamine is neutral, and this is multiplied by 2. Why? Because this 2 is here. This is sulfate. This carry 2 negative charge. Okay, and this is coming for 3 times. That's why this 3. This is 3 multiplied by minus 2, and this is equal to 0. If you find out the value of X, that is 2X plus 0. This is minus 6 is equal to 0, and that's why we can say X is equal to 3. That's why oxidation state of cobalt is 3, and this sulfate is a counter ion. Okay, again don't be confused about this 2 and 3. These 2 and 3 are used to balance the charge. Okay, once again see what is the charge on this coordination entity. You can find out. Oxidation state of cobalt is plus 3. Ethane 1,2-diamine is neutral. Okay, and that's why we can say charge on this coordination entity is equal to plus 3. And charge on the sulfate ion, this is 2 minus. That's why we can say this is 3 plus and this is 2 minus. To make equal charge, this coordination sphere is written 2, and this is 3 is written here. See another example. This in this compound, this cation is also the coordination entity and this anion is also the coordination entity. Diamine, silver first, okay, and in this case this is dicyanido-argentate first. Generally silver form the compound in first oxidation state, okay, and we can say in both the coordination entity silver is present, but this silver is a part of positively charged coordination entity, that's why this is written as a silver. But this silver is a part of negatively charged coordination entity, that's why this will end in ate and we use its Latin word argentum, that is argentate. Okay, now see some more examples. Write the IUPAC names of the following coordination compounds. Now I think you have understood the rules. Again, this is a neutral coordination entity. First write the name of ligands. This is diamine chlorido. Okay, this is diamine, Cl4 chlorido, and this is NO2. This is ambidentate ligand. And in this case, the nitrogen is written first. That's why we can say nitrogen is a donor atom. That's why we will write nitrito N. Okay, this donor atom is represented like this. Metal is platinum and its oxidation state is 2. Again, how this oxidation state 2 came? Platinum is X, NH3 is neutral, Cl is -1, NO2 is again -1, and this is equal to 0. If you find out value of X, this will be 2. X is equal to 2. Okay. Then again this. In this case, this counter ion is a positively charged and coordination entity is negatively charged. Potassium, this is a counter ion. Don't write tripotassium. This 3 is used to balance the charge. Okay, potassium, then write it. This is 3 times 4. That's why this is tri. Oxalato, chromate. Chromium is a part of negatively charged coordination entity. That's why we'll write it as a chromate and oxidation number is 3. This one is in this compound. This coordination entity is positively charged and counter ion is negatively charged. We'll write dichlorido. Okay, and this is a didentate ligand, and in its name already di is included. Ethane 1,2-diamine. That's why when it is coming for 2 times, we use the word bis. Ethane 1,2-diamine, cobalt 3rd chloride. Now again, and this coordination entity is positively charged. That's why this is penta, 5 times amine, pentaamine. CO3 is carbonato, cobalt, oxidation number is 3, and chloride is a counter ion. Now in this case, this coordination entity is negatively charged. Okay, that's why first we have written mercury. How the oxidation state of mercury is 1. Generally mercury form compounds in first oxidation state. Okay, that's why mercury first, and this is tetra, is 4, and SCN is thiocyanato. Again, this is a ambidentate ligand, and sulfur is written first. That's why we can say sulfur is the donor atom. That's why we have written tetrathiocyanato S. Central atom is cobalt, but this cobalt is the part of negatively charged coordination entity. That's why this will written as a cobaltate, and oxidation number is 3. Yeah, thank you.